What happens when you smash the biggest objects in the universe together? Today, we're colliding planets, stars, and entire galaxies. Our first cosmic boxing ring is a freshly formed solar system, still chaotic and swirling with primordial gas and rock. In one corner, we have the contender, HD 100,546b. This isn't just any planet. It's one of the largest exoplanets we've ever discovered, weighing in at a staggering 7 times the radius of our own Jupiter. It's a gas giant of truly epic proportions. In the other corner, its opponent, HATP 67b. While a bit smaller, it's still a behemoth, over 3 times larger than Jupiter. In a young, unstable system like this, orbits haven't settled. Planets are like cosmic pinballs, and these two are on a direct collision course. So, what happens when they finally meet? Their collision speed would be around 134,216 miles per hour. It's a speed that makes our fastest rockets look like they're standing still. First, their incredibly deep atmospheres of hydrogen and helium would begin to touch. This isn't a violent crash, not yet. It's more like two impossibly large clouds slowly pressing into one another. But the pressure is immense. The gases compress and ionize, charging up particles with phenomenal energy. The contact surfaces heat up to thousands of degrees. Then, the real violence begins. Cataclysmic shockwaves tear through the interiors of both planets, ejecting brilliant, searing arcs of hydrogen and helium into the void of space. This creates a blindingly bright flash of plasma, but you wouldn't see it with your own eyes. It would be a silent, ghostly burst of light, visible only in the infrared spectrum. Through night vision goggles, it would be absolute cinema. But the main event is happening deep inside this inferno. After the outer layers have been ripped away and fused, the solid cores of both planets, themselves larger than Earth, finally smash into each other. They crash and merge, forming a single new supercore. Much of the remaining gas from their atmospheres is blasted away into space, but the rest, caught by the immense gravity of this new object, collapses inward. And just like that, a new world is born from the ashes of two, of Frankenstein's planet. If the combined mass is more than 13 times that of Jupiter, we haven't just made a bigger planet. We've ignited a failed star, an actual, real-life brown dwarf. But honestly, who really cares about planets turning into brown dwarves? It's time to level up. We're moving on from the cosmic nursery to the galactic retirement home, where the true gods of the cosmos are waiting. Next on our collision list are the biggest stars in the universe. In this corner, weighing in at 1,420 times the radius of our Sun, is the red supergiant VY Canis Majoris. This star is so obscenely massive that if you placed it in our solar system, it would stretch out past the orbit of Saturn. But it's not just its size that's incredible, it's also highly unstable. Like a cosmic king in his final days, gravity is starting to lose its grip on the star's outer layers. It's been bleeding mass for centuries and is terrifyingly close to going supernova. But not before we introduce it to its dance partner. In the other corner, the largest known star by radius in the entire universe, RSGC1F01. At around 1,530 times the size of the Sun, it lives in a tight little cluster of other doomed giants. Think of it as a galactic retirement home, full of elderly behemoths enjoying their final days. The only difference is that your grandma doesn't end her life by exploding with the force of a trillion nuclear bombs. Now imagine these two ancient colossal stars somehow slam into each other. At first, it would be deceptively gentle. Their outer layers, mostly hydrogen, would collide not with a bang, but with a slow, cosmic puff. It would look like two smoke clouds trying to start a fistfight. The atmospheres would compress, heat up, and partially ionize into a low-energy plasma. For a moment, they would look like stellar Siamese twins, joined at the hip. But deep inside their cores, dense spheres of heavy elements forged over millions of years are drawing closer. And when they finally meet, it's a disaster. The combined mass instantly exceeds the threshold for stability. In the cosmic tug-of-war between pressure pushing out and gravity pulling in, gravity wins. It always wins. The result is a complete core collapse. The larger core absorbs the smaller one, and in less than a second, quicker than you can blink, the temperature spikes past 3 billion degrees Celsius. The very atoms inside start to fall apart, their nuclei ripped to pieces. This releases a flood of neutrons into the core, the pressure becomes unbearable, and the whole thing blows itself apart in a special, hyper-energetic type of supernova. The outer atmospheres that were so gently merging are now blasted outwards at thousands of miles per second. The combined dead core, too massive to exist as anything else, collapses under its own insane weight to form a black hole. What happens when we collide the biggest ones we've ever found? Prepare yourself. We're now dealing with the ultimate cosmic heavyweights. In this corner, the supermassive black hole Ton 618, a gosh darn vacuum cleaner at the edge of the observable universe with a mass of 66 billion suns. And its opponent, a true monster from the legendary Phoenix cluster, Phoenix A. This beautiful gentleman is no gentleman at all. He is a 100 billion solar mass black hole that makes Ton 618 look tiny. So what happens when two of the heaviest objects in the universe smash into each other? Well, they don't just crash. That would be too simple. Instead, they begin an ultra-slow death spiral. They would orbit each other for billions of years gracefully, silently, all while leaking colossal amounts of energy into the cosmos in the form of gravitational waves. It's the sound of space-time itself screaming, quietly. As they get closer, their speeds spin up, dragging everything around them into a maelstrom of chaos. Space-time itself begins to stretch and flex like a rubber band about to snap. Then their edges, the event horizons, the points of no return, finally touch. For a split second, the newly merged object isn't even round. It's a stretched, wobbly, distorted mess of pure gravitational violence. Imagine a jellyfish having a complete meltdown. This single merging moment releases more raw energy in invisible gravitational waves than all the light from every single star in the visible universe combined. You couldn't see it, but if you could feel it, it would be the most violent event in history. Only a special detector on Earth, or perhaps aliens with giant gravity-sensitive ears, could even detect it. And what's left? A new, even more terrifyingly massive black hole. A silent god in the dark. But we have to go bigger. Now we smash entire galaxies, and now we witness galactic cannibalism. Our first galaxy is UGC 2885, nicknamed Godzilla's Galaxy. And that should tell you everything you need to know. It's about 2.5 times wider than our own Milky Way. It's the quiet, tall kid in the class who never speaks but could beat up everyone if he wanted to. Facing it is ESO 383-76, a supergiant elliptical galaxy. This thing is a cosmic sponge. It has already absorbed multiple smaller galaxies and just kept on going. Think of it as the final boss of galactic consumption. Imagine these two titans smashing into each other at hundreds of miles per second. First, their invisible dark matter halos collide, warping and distorting the fabric of space itself. Then, their vast clouds of interstellar gas crash into one another. This violent collision ignites starburst regions, celestial nurseries where millions of new stars are born in a cosmic blaze of glory, at a rate of 1,000 a year. For comparison, our Milky Way makes one. Godzilla's galaxy, with its beautiful spiral arms, would be torn to absolute shreds. Its delicate structure unravels as ESO 383-76, the great elliptical beast, doesn't even flinch. It just eats it. The supermassive black holes at their centers are pulled into a gravitational blender, spiraling in towards each other to deliver the final killing blow. After billions of years, a new supergalaxy emerges. It's smooth, elliptical, featureless, and utterly dead inside. A quiet, bloated giant floating in the dark. You'd think that has to be the limit. Surely that's as big as it gets. We're not even close. Next, we collide the very things that galaxies themselves live inside. If you imagine the universe as a gigantic, three-dimensional spider web, the glowing threads would be cosmic filaments. These are the highways of the universe, vast strands of gas, dark matter, and entire galactic clusters all connected by gravity. So let's take the largest known structures in the entire universe and smash them together. Our contestants. First, the huge LQG, a 4 billion light-year-long filament containing 73 quasars, each one brighter than an entire galaxy, an ancient monster born when the universe was just a toddler. But facing it, the undisputed champion. The largest thing we have ever observed, the Hercules Corona Borealis Great Wall. If you thought 4 billion light-years was a lot, this one is an almost impossible 10 billion light-years across. It stretches across 1/10 of the entire observable universe. Its very existence is a violation of the cosmological principle, the idea that the universe should be evenly spread out at large scales. It shouldn't be real, but it is. A collision between these two is so unlikely it borders on fantasy. But let's defy the expansion of the universe and make it happen anyway. This wouldn't be an explosion of matter. It would be a fundamental restructuring of the entire framework of the universe. Galaxies would be ripped from their filaments and flung into the void. Quasars would blink out of existence or reignite with terrifying brightness. The dark matter halos holding everything together would warp and flex, sending shockwaves rippling across the cosmic web over distances so vast it would take the signal billions of years to cross. The energy release would be incomprehensibly huge. It's not a bang. It is a total system reformat. Congratulations, you have just witnessed the largest, most energetic collision that physics allows. But just when you thought we were done, the final boss appears. And it's the absence of everything. We are now at the edge of the supervoids. Places in the universe where stuff simply forgot to exist. No stars, no galaxies, no filaments. Just emptiness. Imagine the two largest voids we know of, the Boötes void and the KBC void, somehow overlapping. What happens when nothing collides with nothing? There would be no crash, no explosion. The darkness would just grow. The few lonely filaments surrounding them would stretch, dilute, and vanish. Gravity would lose its control over these vast cosmic deserts. It wouldn't be a collision of matter, but an expansion of emptiness. It is the cold, silent end. The last light of the universe wouldn't be snuffed out by a cataclysmic explosion, but by the quiet, creeping victory of nothingness. The true end of the universe isn't a bang. It's a whisper, fading into absolute silence. So, from planetary firestorms to the entire universe reformatting itself, and finally to the triumph of nothing, we've pretty much seen it all. Your brain is probably feeling a little bit smashed and restructured right now. If you enjoyed having your sense of scale completely and utterly shattered and want to witness more cosmic chaos, do us a favor. Don't just click the subscribe button, smash it. Unlike these cosmic collisions, it's completely safe. We promise.